May I present to you, Doc, the statistical tools that I have read based on the thesis entitled Construction Delivery Systems, a comparative analysis of the performance of systems within the school districts by David Morad Caldebella, PS in Civil Engineering, State University of Maranhão, 2000 BS in Business, Centro Universitario do Maranhão, 1998. 6.4 Statistical Tools. Different types of statistical tools are used in the study in order to compare the performance of the three delivery systems. One-way ANOVA and the two-sample t-test are used to analyze continuous variables, while the chi-square test is used for categorical analysis. This section presents and briefly discusses the tools used in this study. However, it is not the intention of this document to present a detailed description of the test. 6.4.1 One-way ANOVA. The statistical methodology for comparing the means of several populations is called analysis of variance, or simply ANOVA. One-way ANOVA consists of the analysis of only one way of data classification. For example, the comparison of the means of cost growth of the three types of delivery systems. According to Mori and Mackay, ANOVA tests the null hypothesis that the population means are all equal. The alternative is that they are not all equal. This alternative could be true because all of the means are different, or simply because one of them differs from the rest. Summarizing, ANOVA tests the two following hypotheses based on an F statistic. Side-by-side box plots are a good preliminary way of visualizing the results of a ANOVA test. In case the plots overlap each other, it is more likely that there will be failure to reject the null hypothesis. However, if there is small within group variation and there is no overlap of the quartiles as shown on the box plots, the difference among centers is more likely to be significant, and there would be enough evidence to reject the null hypothesis and conclude the alternative one. One of the requirements of the task is to assume that the standard deviations of the populations are equal. In ANOVA, a pooled standard deviation is used. As a rule of thumb, it is possible to assume that the standard deviations of the populations are equal every time that the following something standard deviation relationship is satisfied. So we have largest S over smallest s is less than 2.0. This rule is used in the study. Another requirement of the task is related to the normality of the population. According to Mori and McCabe, the central limit theorem allows us to use normal probability calculations to answer questions about sample means from many observations even when the population distribution is not normal. As a sample size guideline, the following points can be considered. A. Small sample size where n is less than 15 need population to be normally distributed. B. Medium sample size where n is greater than or equal to 15 but less than 40. Some skewness in the distribution of the population is okay. Letter C. Large sample size where n is greater than or equal to 40, strong skewness in the distribution of the population is okay. The sampling distributions of the study will be tested for normality whenever necessary to validate the results obtained. Section 6.4.4 presents a brief discussion of this test. 6.4.2 Two-sample T. The two-sample T statistic is a statistical methodology for comparing two population means. It is basically the same methodology used in the ANOVA test. However, this test uses the t-statistic and its p-value to analyze the significance of the difference in the sample means. Two-sample t can be performed as one or two-sided. The following table indicates the null and alternative hypotheses for both one- and two-sided tests. Table 6.3 Hypothesis Test for Two-Sample T. The advantage of this test compared to the ANOVA test is that there is no requirement for equality on populations' standard deviations. Both pooled and non-pooled situations can be used. However, the requirements for normality are the same. Two-sample T will be used as a secondary methodology in this study. 6.4.3 chi-square. The chi-square test is used to verify the possible relationship between two categorical variables. In this test, a two-way table is created and the observed counts are compared to the expected counts of the cells. According to Mori and McCabe, the chi-square statistic is a measure of how much the observed cell counts in a two-way table diverge from the expected cell counts. Therefore, the chi-square tests the following hypotheses. We have the null hypothesis: row and column variables are independent. There is no relationship. HA, or the alternative hypothesis: row and column variables are not independent. There is a relationship. If the difference between expected and observed counts is large, there will be enough evidence against the null hypothesis, where small p-value and in favor of the alternative one. The chi-square distribution is an approximation to the normal approximation for a binomial distribution. The approximation is more accurate as the cell counts increase. In order to validate the test, it is necessary that at least 80% of the expected cell counts must be greater than 5, with the exception of 2 by 2 tables where all 4 expected cell counts have to be 5 or more. Because it isn't always possible to achieve the required cell counts, cells are combined or excluded for some tests. 6.4.4 Test for normality. The sampling frequency will be tested for normality. These tests will be performed to validate the methodology used. Minitype presents 3 different types of normality test: Anderson Darling, Ryan Joyner, and Kolmogorov-Smirnov. It is beyond the scope of this document to describe or detail such tests. According to the Minitab Help Menu, the normality test generates a normal probability plot and performs a hypothesis test to examine whether or not the observations follow a normal distribution. For the normality test, the hypotheses are: HO data follow a normal distribution, while the alternative hypothesis data do not follow a normal distribution. In this case, a p-value will be generated and the null hypothesis will be tested for validity. In case of small p-values, there is enough evidence to reject HO, and data will be considered not normal. Otherwise, it will be considered normal. In this study, if the p-value is greater than 0.10, the sampling distribution will be considered normal for the test. Also, for a more conservative approach, the Anderson-Darling test is used. The results will be solely based on the analysis of Minitab outputs. It is beyond the scope of the study to manually verify the test. Mathematical modifications can be applied to the values of a variable in order to decrease its variability. Transformation is commonly used in statistics as an alternative to bring data to a normal distribution. Therefore, Whenever the test for normality fails, a natural log transformation will be applied in the analysis. In order to overcome the problem of null and negative variables during transformation, a constant will be added to move the minimum value of the distribution to 1.00. This is based on Osborne 2022. Again, the statistical tools that are used based on the thesis that I have read are the one-way ANOVA, two-sample T, chi-square, and test for normality. So that's all, Doc. Thank you so much. By the way, Doc, I am Abuso, your Ed 603 student.